Hello and welcome back to Cracking the Cryptic. And if you are looking at this as it comes out on Friday at 11 p.m. my time, then do feel free to go over to the live stream where we began an hour ago. Simon's having a go at a game called The Pedestrian as part of the Cerebral Puzzle Showcase, and that is going to be worth a look, I would imagine. If you, on the other hand, stay to watch this video now, you are one of my favorite people. Thank you. Now, Simon has pointed out I've been getting something wrong lately, and that is the Tapper puzzle. So Simon's solve of the Tapper puzzle is the one on Patreon. Takes about an hour or something like that. Thomas Snyder's solve of it is the one we put up on the channel, and the puzzle is by Serkan Yürekli, not Niverio. I've been getting my Turkish geniuses mixed up there. Sorry, but that's put straight now. Obviously, you can also check the links under the video for all our apps. And our merchandise, which for some reason has got disconnected from our YouTube page, and YouTube are looking into this for us. We don't know what the heck has happened. If you want our merchandise, you have to, I think, go onto the link under the video and go to our Teespring page. And I don't know what's going on there. We are trying to get that resolved. But you probably cannot see a store tab on our page at the moment to look for our merchandise there. But anyway, that is all going on. You can check out the links to Discord and Sven's SUDOKU PAD as well. They're all on under the video. But the first one is to this puzzle, which is by Audrin from Hungary. And he has again, he was kind enough to approve my title for his last puzzle of Assassinate, because it involved Killer Sudoku and was an 8x8 grid, and he suggested that maybe this one is Assassin 9 therefore, which is clever. So that's what it is. Now, yet again, it is an irregular Sudoku, so the regions are not the normal 3x3 boxes, not even that one is normal, and therefore we can't write normal Sudoku rules apply. The rules are these: 1 to 9 appear in each row, column, and marked region. Like that. Digits in a cage sum to the given number. Those three must add up to 18. Digits on an arrow sum up to the number in the circle. So those three must add to that digit. And that's it. There seem to me to be very few arrows and cages for such a puzzle. But there we go. I don't know how this is going to play. Do give it a try if you fancy it on the first link under the video. I am going to start now. Let's get cracking. Okay, well, what I like to do with 3-cell arrows where the digits all have to be different is fill in 6, 7, 8 or 9 in the circle, because the minimum for 3 different digits is 1, 2, 3, and all of these 3-cell arrows are contained within a region, so they do have to be different. And this is a pattern I've seen before. So 3 cells that side and 2 cells that side, I think is ruling out 6 and 7. The simplest way to see that is imagine this was a 7. Then these 5 cells have to add up to 14, but they're all in row 9, so they all have to be different. And the minimum for 5 different cells is 15. So this is an 8 or 9. If it's an 8, I think there's only one way of doing this. 1, 3, 4 there and 2, 6 there. But it can be an 8. And I mean, I don't know, not much of these cells aren't really looking at each other. This can be anything from 3 to 9. Okay, so I'm going to have to focus on the regions somehow, I think. We can apply the law of leftovers if we look at these last 2 columns, for instance. Obviously, that's 2 sets of the digits 1 to 9 by the rules about columns. But this shape is also 2 sets of the regions 1 to 9 by virtue of the rules about regions. Now, the only difference between that collection of 18 digits and this one is these 2 cells that I've left marked. And I think that means they must be the same. So I'm going to colour them purple. The same applies over here because we've got a mirror symmetrical grid. So that digit is the digit missing in those cells from column 2, so it must be here. I mean, sorry, that may not be obvious, but obviously it's missing from those cells because it's already in that region. Therefore, it's in these cells. Sorry, no, therefore, in column 1, it has to be in these cells. And therefore, it's ruled out of those cells as well as those cells. So, I mean, it does work both ways. But I don't think there are any other lines we can draw that give a good... Oh yeah, there is. There's one across under row 8. These two cells are going to have to be the same as these two, but I'm not going to colour those because I might get confused and assume that one green cell was always the same as another, and it could be instead the same as that one. So what can you see here? What are we meant to do? Sorry, is it to do with these arrows? I suppose they contain smallish, no, it might be down here. So if this was an 8, we'd have 1, 3, 4 there, 2, 6 there. These 3 cells would be 5, 7, 9. So would these 3 cells. I don't know if that means anything. Oh. Ah, right. Okay, now something that we haven't properly used yet is the secret. The secret that every row and column and region in this Sudoku contains the digits 1 to 9 and therefore adds up to exactly 45. Yes, okay. Well, I don't know. Let's have a look. I'm going to have a, this might be profitless, but I'm going to have a look at these 2 rows. They contain 2 sets of the digits 1 to 9 because rows have to. But we can, okay, we can take out one of the sets of the digits 1 to 9 by removing that region. And okay, this is another way of looking at the law of leftovers, is you sometimes get left over with a set of 9 digits that are a set of the digits 1 to 9. And the blue cells in this case are a set of 1 to 9. Now, oh yeah, that's interesting. So if this was a 9, then these add up to 9. That's a total of 18 here. This cell can't be more than a 6. And these ones can't add up to more than 8. So the maximum for these cells taken together is 18, 26, 32. That leaves a minimum of 13 for those two. Now how would it work? If that was a 9, they could be an 8 and a 7. This could be a 6. I don't think this can be as low as a 6, or maybe even a 7. If this was a 6, oh yeah, look, if this was a 6 here, that would be 1, 2, 3. These would be at least 4, 5, and they'd already be breaking that. So that's not a 6. Now, can it be a 7? If it's a 7, these are 1, 2, 4. These have to be 3, 5 then. So you could put a 1 and a 9 down here. That has to be 6. Maybe that is possible. These end up being 7, 8, 9, which happened before. Oh, of course, that... Oh, so slow. Sorry if you're shouting this. Yeah, we've worked out that these blue cells are an extra region. Where does 7, 8 and 9 go in them? That's the nice question. And it works really prettily, actually. Because one of those can go here. That's fine. But a 3-cell arrow can't have a 7, 8 or 9 on it when the other two can see each other, because they'd have to add up to 7 plus 2 plus 1 is 10. This one is in the same predicament. It cannot be as much as a 7, or you'd get to 10 before you got to the circle. And the same is true here. So none of these arrow cells can be 7, 8 or 9, and that only leaves room for 3 of them in the puzzle, in the blue region, in those cells. That is a triple. An odd one, but it is a triple. Now, what next? Well, these, by virtue of these being an extra region, all these cells sort of see each other. They're in the same effective region. So they have to be at least 1, 2, 3, 4, 5. They have to add up to 15. Plus a digit here means that these two circles have to add up to at least 16. So this one can't be a 6. And now we have another 7, 8, 9 triple. Or put another way, because those are different and those are different, then these two are now the same. And I've just announced that they have to add up to at least 16. So they're not 7s. So there is a 7 here. Are they 8s or are they 9s? If they were 8s, then again, these would be 2, 6. No, 2, 5. Oh, I don't know which way around, but they would be 1, 2, 3, 4, 5. And this would be a 1. No, this would be a 6. Yes, that's right. That would be 1, 2, 3, 4, 5. This would be a 1. This would be a 6. And that is possible. Bother. So I can't rule them out from being 8s. Okay, this 12 cage is either, it doesn't have a 7 in, so it's either 8, 4 or 9, 3. Now we've got a virtual 7, 8, 9 triple in the row, because that has the other one that isn't in those two. So none of these can be 7, 8 or 9. That doesn't really help a lot. Oh, can we carry on with orange though? Look, yes, we can do an interesting thing with orange now. Orange now cannot be in, well, first of all, it can't be in these cells because orange is the same. We don't know whether it's 8 or 9, but it's the same across the grid here. So it can't be anywhere else in row 6 and 7, and it must be in one of these 3 in row 8. But it also can't be here or here because we've done one in column 1 and one in column 9. And therefore it can't be here or here. But in this bottom row, it's 8 or 9. It can't, oh, it could be 8 on this. If that's a 9, it could be 8, 1. Oh, bother. I was going to confine it to one of those two cells. I can't do that. Okay, not to worry. Can I do anything else with this crazy orange? Yeah, I can do another thing. Look, up here, it can't be on those cells. 8 or 9 is too big to be on a 3-cell arrow. So this orange is seeing all of those cells, and it can't be on those two. So orange is in one of these 3 cells in box, whatever box number we call that. Let's call it box 3. And the same's true here. It can't be in those, so orange is in one of these 3. But it can't be yellow, because 8 or 9 is too big to be on a 3-cell arrow, so it's not there. So orange is now in one of these 2. And it's in one of these 3. So in this box, we've used both the oranges in rows 3 and 4. There can only be one in each row. So the orange in this box is in row 2, somewhere here, which matches orange there. And it's in this region in row 5. And that is like a sort of swordfish, isn't it? Using up oranges in 3 rows. I don't know, I might mean a jellyfish, I never quite know. Now, what does that tell us? Yeah, sorry, it's using up the oranges in 3 columns and 3 rows. That's the exciting thing, in a way. So orange in this region now can't be in those columns because the 3 oranges are in some of the cells we've labelled. Can't be in those rows because of that and that pair. And therefore is in one of those two cells. Oh, no, 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 no. Where does orange go in column 3? Oh, that's pretty. That's mega pretty. Right, orange can't go there because of that group. It can't go here or here because of those pairs that use up oranges in rows 3 and 4. It can't go here or here because orange in this region is in those two cells. Can't go here because of that, or here because of that group, or here because that's on an arrow. So orange in column 3 is right there at the top. That's not orange. Can we pull the same in column 7? Not quite. Ah, it's so close. I'm sure it's there. But I don't know that. Oh, blather. Because it can be an 8 here, can't it? An 8, 1, 9. You always have to remember, if you're placing 8s and 9s, that 8 can go on 9's arrow. Oh, tripe. I don't know. What have we proved? We proved there isn't a 1 in this range, in this cage. That's totally uninteresting. Ah, I got quite a long way with this orange, but not quite far enough. Can't be in any of those cells. Or that one, actually. That's quite a lot. So, orange in the bottom row is definitely in one of these two. If it's there, then we've got an X-wing there. If it's there, then it's there. Okay, well, fair enough. We don't know the answer to that. That is a shame. Okay, something we do know that I think is quite interesting is that this is not orange. Partly because we've placed it in one of those two, but earlier because we got it to those 3 positions in these columns. So that is a different version of 8 or 9 and is green, let's say. I mean, I'm just making up the colour. Can we place green anywhere? It's in one of those 2 cells. Oh, come on, is that all? Can't be there now. Ah, yikes. Well, it's not yellow, so it's not there. So in this region, it's in one of those 5. That's really not helpful. So never mind about that. Okay, let's have another thing. I mean, I want to know what these numbers are. That's what I want to know. So let's try these being 8 again. Oh, no, let's think about... These add up to at least 15. The total of these arrows... No, the total of the remaining blue cells is 21. Because blue is a region, remember. We've used 9, 8, 7. The others add up to 21. These ones add up to at least 15, but no more than 18, because those could be 2, 9. In fact, they add up to either 16 or 18. That's what they do. So this is 5 or 3 to make up the balance of 21. Is that right? That is right, I think. No, it's not. It's not right because I'm taking this, I'm adding this cell in. Okay, sorry, let me think this through again. These could be 8 and 8, 16. Then these cells would add up to 15. This one would be a 1. And this would be a 6 to make up the 21 total. Now, if these were 9s, which they might be if orange is 9, that's 18. Then these can add up anywhere from 15 to 17, leaving this to be 1, 2, or 3, and leaving this to be 6, 5, or 4. So it's one of the higher digits. Now, there is a rule that when you're adding 3 cells to make any number up to 9, at least 2 of them are from the low digits 1, 2, 3. And I mean, you can see that because if you tried to put 2 4s on an arrow, if you were allowed to, you would get 4, 4, 1, and you'd be repeating a digit. Any number you go higher than 4 is going to break that worse. So these 2 are low. These are from 1, 2, 3. So we've got a triple of 1, 2, 3 in this row. Oh, of course, and these remaining blue cells add up to 21. And this triple of 1, 2, 3 adds up to 6. 21 plus 6 is 27. There's only one way to make that up in these 3 in these 3 circles, and that is 9 apiece. So they're all 9s. This is orange now. Those aren't. This is. This isn't. This is. Yes, these are now an 8-7 pair, and therefore there is a 9 in this cage. It's a 9-3 cage. So we've got some digits. Hurrah. We know, okay, that's a 9 as well. We got that earlier as orange, definitely. There's a 9 in one of those 2, a 9 in one of those 3. These 2 can't be 9 anymore. Now that's getting interesting. They've both got to have a 1 on. And that means 1 in this region is in one of these 2 cells. In the horseshoe. What else are we getting from this? We must be getting something. I don't know what they add up to, because that is going to be 3 less than that, I think, is the way this works. If that was 2, 3, 4, and that was 1, 5, this would be a 3 and that would be a 6. Yeah, I think that relationship applies. Don't know how to use it. Green, we know, is not 9 now, so that's 8. There is a 9 in one of these 2 cells. There's a 9 in one of these 3. Where's the 9 in row 2? It's in one of these 2 cells, isn't it? Yes. Probably in the circle, but we haven't proved that. Oh, now we know 9 can't be on the arrow of 8. Of course, that doesn't work that way around. Right, so we've placed this. This is orange and purple, if you like. I mean, it is the same. In fact, it's 9. Yes, once 9 is here, it can't be in these 2 cells. So let's, I don't know, let's get rid of the purple colour, and we don't need purple anymore. We know they're both 9s. That places 9 over here. That is where it is. I don't know what's happening. Okay, right. So we've got a lot of 9s done now. At some expense in thinking and time. Now, 8 here is a 2-6 pair over this side and a 1-3-4 over this side. It has to be. The other bits of the cage and the row are filled with 5 and 7. This is in a region which has got a 7-8 pair, so that's a 5. This can't be 7 anymore. It's 6 or 8. There must be... Okay, where do 8, 7 and 6 go if they can't go on these arrows anymore, and they can't? 7, for instance, goes in one of these 2 cells. Oh, where do they go? In the top row. 8, 7 and 6 must be in this group. Now, this 18 cage could be 7, 6, 5, so 8 doesn't have to be in it. It could be, it's going to use 2 of 8, 7, 6, not all 3. So it's either 8, 7, 3, 8, 6, 4, or 7, 6, 5. I don't know the answer, I don't think. Oh, I know what... No, I don't know. Yes, I do know what these 2 are going to add up to. They're going to add up to 45 minus 15 is 30, minus 5 is 25, minus 9 is 60, 15 minus another 9, they add up to 7, and they don't involve a 5. So they're 3, 4, or 1, 6. Can I not use that? I mean, I know what these 4 add up to, but I don't know what those 2 do. So maybe I can't use that at the moment. Okay, let's have a think about the 7 that's up here somewhere. If it's there, this is a 7/4 cage. If it's there, then this is either a 6/5 or an 8/3 cage. Now, if that was a 6/5 cage, you've got 8 here, 1, 3, 4, 7, 2. If it's a 6/5 cage, that's just what I did. If it's an 8/3 cage, it can't be an 8/3 cage. You'd get 6 and 1, 2, 3, and the 3 would clash. So this is either 7/4 or 6/5. That can't be it, the 7. Maybe there's an interaction between those. I mean, obviously they can't both be 8s. Absolute knowledge bomb there. So they make somewhere between 13 and 17. Is 13 too low? No, you could have 1, 2, 3, 4, and 1, 2. Sorry, if I said from 13 to 17, I meant from 13 to 15. Don't know what to do with that. Come on, keep going. This is the sort of time in a puzzle where I get so worn out that I just start either not being able to see anything or making crazy assumptions. And that's probably about to happen as I say that, but anyway, we'll see. No, I was going to say there's got to be a 5 in this cage, but it could be here, so that's not important. Oh, okay, if this is 3, 4, then the 9 arrow is 6, 2, 1, and that would take 6 out of here. If this is 1, 6, then it's 4, 3, 2. I don't know how to use that. Okay. Yellow is 1, 3, or 4, so that is 1, 3, or 4. Oh, where's the other 7 or 8 in column 2? It's not on that arrow and it's not on that arrow, so it's in that cell. Oh, where's 5 now in column 2? It's not in this region, or in that cell, or in those 2, so it's on this arrow. So it's a 5, 2, 1 arrow, making 8. Aha, that was a good question, or a good pair of questions. Then we get 6 over here, and this is a 1, 2, 3 arrow. This is a 7, 4 cage. I feel like we've actually suddenly got something done here. This is a 5, 8 pair. Now, come on, 1, 2, 5, 9. Yellow is not 1 anymore, because we've already got a 1 in this cage. Oh, that's a 7. That fixes 8 and 7 here. Let's do the colouring just to keep 8s going. I don't know why, really. I'm not using them for the colours, but might as well. Now, these are from 3, 4, 6. That one can't be a 4. In this row, we've used 9, 5, 8, 7, and a 4 there. So these are from 1, 2, 3, and 6. Ah, so 4, 7, and 9, which can't be in this row, are a triple up here. Goodness me. Oh, I've got rid of the 9 colouring. I'm going to restore it. And that's not a 9. There we go. 4, 7, 9, 8, 6. These are from 1, 2, 3, 5. I think we've said they're not 1s. And I can't remember how I thought I determined that earlier. Oh, yes, we've got a 1 X-wing here. Yes, so they're from 2, 3, and 5. Oh, now this group of cells is 4, 6, 7, 8. Look, that's a 1, 2, 3, 5 quadruple. These are from 4, 6, 7, 8. The ones, I mean, that's a total of 25. To get to 18, we remove 7 from that cage and put it in there, and that's a 4, 6, 8 cage. These are from 1, 2, 3, 5 to complete this horseshoe region. 6 and 8 must be in these cells. I don't think I've learned anything about what this is, so not. Oh, 6 and 8 are in these cells, so that becomes a 3. No, I'm not 6 and 8. Sorry, I misread the 6 down here. 5 and 8 are in these cells for this region. So 5 is not in those two, and is in one of those, and isn't here, which I could have worked out from the fact that in this quad it has to be on the left, just as 3 has to be on the right and isn't here. So in fact, that's a 1-2 pair. So I could have done that by the maths of knowing that 14 was a 1, 2, 3, 5 quad and a 1-2 pair. And that means this is a 3-5 pair in this region, and this is a 1-2 pair in the horseshoe region. And I still haven't found out what this digit is. 9, 1, 2, 7, 4. No, I haven't, and deservedly not. These are from 3, 5, 6, 8. That could still be an 8, or a 6, or a 5, or a 3. Okay, no idea there. 7 is looking down here. Sorry if you've noticed that a long time before I did. That's fair enough. Haven't quite got a 1, 3, 4 triple going there. Looks a bit like I've only got one place to put a 6 there, but it's not true. I could put a 6 there. Oh, come on. These can't have a 3 in because of that 3-9 pair. So this either goes, it could still go 3-5-1 or 3-4-2. I just don't know. Okay, 6. No, that can be on the arrow too. Ah! Okay, 5 is looking up at that. Okay. Just some regular Sudoku. There's probably quite a bit more if I just knew where I was meant to be looking. Let's get rid of the pencil mark. It doesn't seem very useful. Now, come on. 9, 5, 7, 8 is in one of those two. And one of those two. That's quite surprising. 7, 3, 1, 2. It's true though. Yeah, I don't think I've done anything wrong. 8 is an X-wing in rows 6 and 7 there. So the 8 in row 8 has to be in one of these. Doesn't look that helpful now I've done it. 6 and 4 can't both be on the arrow, so at least one of them's in those two cells. That's not a sort of usable conclusion. Come on. Oh, the 9 cage can't be 3, 6, 5, 4 or 7, 2. This is 8, 1, so we know where the 8 in this region goes now. Right. And that 1, I don't know that there was a 1 on this. It could be 4, 3, 2, but otherwise that's a 1. And then it's 1, 2, 6. So 1, 3, 5 has been eliminated because these can't both be from 1, 3, 5. So it's 2, 3, 4 or 1, 2, 6. And there is a 2 on it. And that probably doesn't help at all. Well, it takes a 2 out of these cells. I don't know how it helps. Right, 1, 8 there. That has fixed this as a 2. And that as a 1. This becomes a 6, and we get a 4 to finish column 7. That's not a 1. So we know where the 1 is in this arrow. There. That's not a 1. That's not a 2. That's a 3, 4 pair. So this is a 2, 6 pair. Now we've got 4, 5, 7 to complete the region. That's not a 7. 7, 8, 3, 9, 1. So that is 2 or 5. This is 2, 4, 5 or 6. So we could still go 2, 6, 1. This can't be a 5. That wouldn't work with a 2 here. And a 2 wouldn't work here either, because that would have to be a 5 and that would be another 2. So 2 is not there. This is 4 or 6. So these are either 2, 3 or 2, 1. And that is now where 2 is. I'm buying that. Okay, that's a 1 or 3. The 2 has forced this to be 6, 2. That forces this to be 4, 3. Let's tidy up a 5 there. Take 5 out of those cells. Now, what's going on over here? Can't be 2, 4, 7, 8, 3, or 9. So it's either 1, 5 or 1, 6. And this is either 2 or 3, and I still haven't finished. Okay, that's fine though. This is 5 or 6. Oh, well, we knew there was a 1 there now. That doesn't get anything done there. That can't be an 8, nor can that, just by looking up the column. And that can't be a 2. Maybe I've just missed some simple elimination. Still don't know what yellow is. 2, 4, 3, 9, 7. There's a 6 in one of these two. 8, 6. 1 and... Oh, there's a 5 in one of those two. Oh, good grief. What a puzzle. Just keeps on going on and on at you. I thought there was only one position for 6 in that column for a moment. I was wrong. It looks like there might only be one position for 2 in this column. Actually, that could be very helpful if that's true. Why don't I think this can be a 2? I think possibly by mistake, so I'm not sure I want to rely on that. That's, oh no, hang on, I worked out these two added up to 7, didn't I? How has this got 2 possibilities? Because I hadn't spotted that there's a 5 in the region, right? So that's a 1, 6 pair. That's a 2, yes. So 2 in the first column is there. That does 2, 1, 5. This is now a 1, 3 pair. We know the order now. That's a 2. Actually, I should have got that from the 3 earlier. So 1 is in one of these 2 cells, and this is a sort of chocolate teapot quadruple. That can't be a 2. So 1, 3 there. Of course, this has become a 5. I could have got that from the 1, 6 pair. This now isn't a 5. I don't know, I don't want to be looking for quads. I've got a 3, 6 pair there. So that's a 5, 8 pair now. 7, 9, 5, 8. Oh, in fact, there's a 5 looking at it. That's not an 8, so we can place 8 in the top row. Oh, I was going to keep colouring the 8s green and just forgot. So let's do those ones before green thinks it's not jealous anymore. Oh, I'm sure this is all coming now. That might be doable, but I'm still not going to focus on that yet. Now, this region, 8, 5, 9, 1, 3, 4. So we need a 7 and a 2, 6 pair. So this is now a 3, 4 pair. That's been obvious for a while. This must now be an 8, 1 pair. So that figures out which way round we go with 1, 8, 6, 5. That sorts out 8, 5 up here. Let's colour those green 8s. And now we are surely on the home straight. Okay, I'm finally going to look up this column. No, I'm not. I'm glancing to the side. I'm spotting a 4, 7 pair there. So we get a 6 at the top, 4 there. That might help with the column, although not much. That's not a 6 anymore. It's part of a 1, 3 pair. 7 sees that cell. 4 there, 7 there. That's not a 4. So 4 in this region is done. That is now, 7 is looking at that cell. So we get a 9. Ooh, unexpected. A 9. I promised virtually earlier that the circle would be a 9. I didn't promise it, but I thought it was true, and I was wrong. So this is 9 here. 9, 3. That's not a 3 anymore. I'm going to look at that arrow in just a moment. I'm sure it is necessary, and therefore it is time to fix it. It must be 7, 6, 1, because 3 there would need a 4 here, and that's not happening. So there we go. That arrow does resolve the puzzle. Yellow finally is fixed. Yellow was virtually the first marking I put in, I think, and I haven't fixed it till the very end of the puzzle, which, I don't know, it feels like a mark of brilliance by Audrin to achieve that. Anyway, 1 there, 6 here. Hopefully this is right. Bingo. What a lovely puzzle. Delighted to do that today. Yeah, that should be blue and orange. Have I missed any 9s? 1, 2, 3, 4, 5, 6, 7, 8, 9. Have I missed colouring any 8s? No, I haven't. They're all coloured. There we go. It's a brilliant puzzle. There are probably slightly more efficient ways of doing that. I'd be very interested to know if anybody found a cleaner start, or, don't point out when it took me 4 or 5 minutes to spot some obvious bit of Sudoku, because there's so much to look at that as it unwinds. It's not a shock. Anyway, thanks very much for watching, as always. Hope to see you again soon. Bye for now.